channel, and today we are going to talk about the what complex number is. This is a whole video lecture series, and this is the first lecture. And in order to solve the lot of problems in mathematics for the real numbers, there are certain ways. Suppose I'm giving you an equation, let x square is equals to 9. You can say that the answer and the value of the x will be 3. If I more elaborated, we can say that it might be plus 3 and minus 3. Similarly, if I give you a number, suppose that an equation, suppose that it is x square is equals to 81, then you can say that the value of x will be plus 9 and minus 9. Okay, it's good. Now, let's talk about the equation whose value is something like x square is equals to minus of 81. If you are not aware of what the complex number is or what the imaginary, or if you are listening to this the first time, most probably you will not able to give the answer that what will be the value of x square is equals to minus of 81, or x square is equals to minus of 1, or x square is equals to minus of 9, or any number. So in order to tackle the problem, what we see, basically x square is greater than and equal to 0. This is the whole equation or a general equation for those numbers who are belonging to the real number of set, where x can be any value ranging from the negative integers or the negative real numbers 0, or the positive integers or positive real numbers. Okay, this shows that there is no other value which can be belong to the minus of x square is greater than and equal to 0. It shows that the value of x will be somewhat lies more than 1. Okay, it also shows that the real roots would be plus 1. They are positive. So it we can say that the value of x, if I can transfer from the left side to the right side, I can say that the value of x will be positive, and the square of real numbers is non-negative. Okay, so x square is equals to minus 1 or x square, as I said earlier, that those values are not even possible to find by the real number of set. So in order to tackle the problem, first we have to know what are imaginary numbers, and after that we will going to know that what are complex numbers indeed. So let's take an assumption, x square plus 1 is equals to 0 and x square is equals to minus of 1. It shows that no real roots are present. So most of the scientists, what they done, they just transfer the square from the left side to the right side and write x square, or x is equals to under root of minus 1. But there was a scientist earlier known as Euler who first used a term known as I, which is also known as iota, and he said the value of I will be equal to under root of minus 1. We are assuming that the value of minus 1 is equals to I. We also know that I is a imaginary real sorry I is an imaginary number. Okay, so when we use this I with a real number like 2 plus 3i, it becomes a complex number. And whenever we use this term, always with a real number, mixing it, and if we multiply or divide something with this, the real number will becomes an imaginary number. Basically we write as a plus ib. This is the general form. Okay, and it also known as a standard form. So a plus ib, that's equal to z, and we can say that a is a real part of this complex number and ib is the imaginary part, where I is an imaginary number, ai, or we can say bi, or 2i, 3i, 4i, 5i, or anything else which is multiplied to I becomes a real imaginary part or the imaginary number. But when we add this imaginary part with the something with the real part, it becomes a complex part. I know that is something very complex to understand, but it is. So if we put the value of b is equals to 0 in the z is equals to ib, we can say that z a is equals to a plus 0 I will form z is equals to a, which is real. And whenever the value of b is 0, it always gives you the real answer. We can also say that the complex numbers are actually the subsets of real numbers. Sorry, it's inverse. We can say that the value of real numbers is the subset of complex numbers. R is a subset of C. We must take a note from here. Two complex numbers are said to be equal when two complex numbers are said to be equal, that is z1 is equals to z2, if and only if a is equals to c and b is equals to d, where z1 is equals to a plus ib and z2 is equals to c plus id. This is all about the complex numbers lecture 1. Meet you in the next video and see you soon. Thank you.